Welcome to the fourth and final episode of our overview on the design process and First Tech Challenge. Episode 1, we talked about what is design. Episode 2, focusing on the engineering and design process. Last episode, we made connections to the current First Tech Challenge season, Skystone, for 2019. And in this last episode, we'll just sort of take a look at things moving forward. Now that you have an overview, what can you actually do to make progress? So, we want to come up with ideas. In the second episode, we talked about ideation and how to learn to be able to come up with lots and lots of ideas, not worry about the practicality yet. And so here I want to spend some time on exactly how to communicate your idea. So I recommend that you get a normal clean sheet of paper. You can either do this in your bound notebook or just get copy paper. Make sure you always name, first name, last name, date, and then put your team number just in case you accidentally lose your paper somewhere. You want to draw big. You want to fill the page so that you can add details later. Often students, if our slide here is a sheet of paper, they draw on this really small square. And one, you cannot see that from afar. And then two, if you want to add details, it's this really small space. And so draw big. But you also want to include some information. You want to state what is your strategy, what is your concept, and what is your design. And I'm going to give you an example of that in the next slide. Here's a summary of the strategy, concept, design from before. And when you are coming up with your idea, this may happen in a team setting, but often this happens on your own. And I really encourage each participant spend some time on your own. I know it feels like homework, but in a sense it is. Set aside a good 30 minutes, if not an hour, to put away all your distractions, all your notifications, and spend some time with all the game information that we talked about in episode 3. And then maybe you do some research on some things that might inspire you. And what you want to think about is you want to come up with your ideas in a quick fashion, but also in a clear fashion. So on one hand, you want it to be clear, so you want to consider taking some time for your thoughts to develop. However, you don't want to get stuck in the perfection land. You don't want to be in an analysis paralysis where you're just trying to think abstractly, will this work, will this not? You want to just share your rough ideas. It's okay that they're rough. We all know that, and we're going to judge and test them later. So don't be afraid of sharing it out. Now, if things are still a little bit unclear and from your picture it's not clear to somebody else, then spend a little time refining that. So for instance, what is the strategy? We're going to deliver stones. What's our concept? We want an easy to drive method that you can just sort of push pieces around, nothing too complex mechanically. And then the actual design. So we could think of having some sort of plow, some sort of angled piece in front. Maybe you have a gate, kind of like a parking gate, that lowers and raises. Or you could have an attachment or make your chassis so that it's almost kind of like a fork so that you can sort of manipulate the piece. And you want to just include other details. What's the scoring potential? Maybe what material you would use. Any sort of thing that you have given some thought to think about. But again, don't get stuck in this perfection land. If you spent a good half an hour on it, if your drawing is legible and people can kind of understand what's going on, just share it out. And other people will help you develop it. And to get a finer, higher fidelity, higher level of detail in your design, that's why we use things like computer-aided design, Onshape. That will get you to a higher level of detail. But when it's this initial idea phase, you want to get your ideas out there. So let's see an example here. All right, I've made a sheet here that has some information of what might be good to share, but also just some points for you. So again, fill the page, make it big so you would add detail. So ideally, your little sketch would be even bigger. Make sure you put the context, any sort of relevant information. We'll get to that in a moment. And this can be paper or digital. I sketched this out. All right, I kind of had an idea in my mind. I did draw this out a couple times as a first draft before I really got what I wanted, and I made this sort of the final. And time is of the essence. All right, the season is going on. You want to get the ideas out, but you also want them to be clear. You don't want to spend a little bit of time on it, share it out to your teammates, but then they don't really understand. So, okay, let's see. Again, strategy, what's your way of scoring? Deliver stones. The concept, how to score. Have a sort of the shape of your chassis here. That would be the shape of the stone, one at a time. And then how are you going to build it? What are the actual components? In this case, this is that parking gate, the hold and release. Maybe you would talk about the potential maximum points and how fast you can do it. It's a little cut off down here at the bottom, but this is the risks, countermeasures, references, anything that would be important. Now, if there's a lot of information to put, maybe you want to keep the sheet of paper as the main visual. Maybe you have a second page that can address the additional pieces of information. This was sketched out on a piece of paper. I've scanned it. You can do a hybrid of it. If you're more comfortable, let's say using Google Slides, just making some boxes and diagrams, that's fine too. Whatever you do to make it quickly and also clearly. Here I'm sort of drawing in this 2-point perspective. If you're not comfortable with that, I mean, it is definitely a skill that you should spend time learning. But if you want to just do side views and top views and bottom views of the robot, that's okay too. So let me go over some reasoning of what I did here. The stone is in question, so I found out that it's 8 inches wide and then 4 by 4 on the side. By the way, this is an example of 2-dimensional views. All right, and we know the max width of the robot is 18 inches. So if I have 18 inches, I take out 8 inches for the stone, and let's say take out 2 inches for the margin, meaning about an inch margin. Inch margin over here, inch margin over there. You know that when you drive up to the stone, it's not going to be exact. And so that gives me, I divide that by 2, and that gives me about 4 inches left on each side. And that's important because my motors and any sort of other transmission would have to go there. Again, here I am focused on how to deliver stones. I don't really care about this other details. Eventually, I have to worry about that, but this is just to communicate an idea. And as I share this with my teammates, we'll be able to figure out, okay, how can I plan out these other components? And again, the finer detail is why we would use things like Onshape. So just to finish off here, there's a servo here. I'm saying that there's a gate, some sort of piece, maybe like an 1/8 inch laser cut piece that serves as a gate that could go up and down. So you drive up to the stone, it gets into the chassis, you lower it, drive to your next spot, and then raise it. I've also put a front, back, left, right. That way, as I talk about this, I can refer to certain points of the view. This is not a live CAD model. This is just a static image, but at least I can have some reference directions so that as I talk about this idea, if people want to build on this idea, then we have ways to communicate it. All right, so just to review some resources that you have, this is our school FTC website that we've tried to compile a lot of resources. And if you find anything that you think is useful, or maybe there's an error or mistake, outdated information, please let me know. This is the official first, I say first national, the official place where they put out documents. And over time, they may make tweaks to the documents. So it is your responsibility to make sure that you have the latest piece of information. And then this also has things like programming resources and robot building resources. This is the forum. So it can get very, very tedious, but people are very helpful. Now, I believe right now only coaches can post official questions. So if you have questions, talk first amongst yourself. Make sure that the answer or the issue is not already addressed. And if it is really something new, then you can let one of the coaches know and we'll post online. And hopefully other people can chime in or the official organizers can provide a response. Okay, just general reminders. I highly recommend individual notebook to document your learning, but then you will have a team Google Doc, one Google Doc as a main journal. If you need to branch off into other Google Sheets or Google Slides, you can, but make that one doc your running commentary and journal and archiving of your team's journey. You'll have a Google Drive that you can put any sort of pertinent documents. Remember, when you show up to lab, have closed-toed shoes to change into, tie your hair back, and no dangling jewelry, name tags, lanyards, or anything like that. Also, you've had a long day of school, and we want you to be present in working on your robot. So if you need to go get a snack, if you need to take a power nap, that's totally fine. But if you're not feeling that well, don't force yourself to be at the practice. Obviously, your team wants you to be there, but if you're not feeling well, don't force yourself because that will lead to mistakes and that could even lead to unsafe practices in terms of somehow getting hurt unintentionally. So just please be mindful of that. It's okay to let one of your coaches, one of the adults know that you're just not feeling it, and your teammates will understand. This is just a proposed week by week big goals for each week of the season. The competitions are here roughly half and half of the season, but depending on your team, these things are going to adjust over time. I've tried to build in a lot of buffer time, a lot of extra time in case things don't go well. But keep this in mind as you are going throughout the season. Towards the beginning, think big, wild ideas, but towards the end, you just want to build and drive a reliable robot, even if it doesn't do everything that you wanted to do in the beginning. Team responsibilities, everybody should be contributing ideas, everybody should be building, and everybody should know how to basically operate the phones and robot. As you get closer, you may have a few people, all right, you should never have only one person who could do something. Just in case they're sick or unavailable for one day, you would need to have multiple people, and you need to document it. But as your robot gets fully formed, there may be a few people who are able to do it well so that you know that if they're around, they're the point person for that. But really, everybody should be able to get a hand on the robot. Now, these are suggested focus areas, just like the different parts of the robot. In terms of having multiple people assigned to it, you want to have at least 2, if not 3 people um, working on these areas. You can have multiple jobs. And hopefully everybody knows enough of the basics to have a conversation about it. They may not be able to teach it. They may not be able to lead the development right away of a particular area, but at least you can have a conversation about it. The last part here is more for game day. You'll have a drive team, up to 2 people to actually drive, depending on 1 or 2 controllers. You'll have a quote unquote coach, which is just another player standing behind you to be able to see what's going on in the game. And new to this year, each alliance can have 1 human player to help load the stones from outside of the field. Then you also have a scouting and strategy team. Now, sometimes there's overlap in between this, and we should probably include a team to stay behind in the pits. But we'll talk more about this as we get closer to competition day. Here's a quick thing you can pause to see what you think the numbers are. All right, there are studies and experiments that you can do to get some data, but it usually takes 3 times longer than people think to do something new. This has been shown before in just folding a basic origami ball. People make an estimation of how long they think it'll take, then they do it, and it takes about 3 times longer than people think on average. Now, when you're talking about making something, let's say machining something or building a project or whatever, the time that usually it takes is 10 times as long. So really just keep that in mind as you go throughout the season. Few last words here. By definition, your rookie season is full of the new. It's uncharted territory. So point being, don't get frustrated if things are hard. Okay, you are learning, your team is learning to work together, and this is an open-ended challenge. But build in time for the unexpected things and be encouraged that many students before you have been able to successfully go through this process, learn a lot, and have fun along the way. Remember that you aren't alone, and what you're doing is hard. For myself, I did not have a chance to do this in middle school, let alone even high school. I had my first experience in college in a similar type of competition. So you guys are really in a good place. Lastly, there's this one quote from an MIT professor who recently passed away. He's a very famous computer science and artificial intelligence researcher. And he had this phrase where he said that you can do it, only you can do it, but you can't do it alone.